Hello there! Now we are to solve this given linear system. We have 3x minus 4y equals negative 6, and then we have 2x minus 3y is equal to negative 2. This is a system of linear equations in two variables. We have x and y variables here that represents a point in the Cartesian plane. They are also considered to be linear equations since the exponents of x and y are just 1. The solution for this linear system is the point of intersection in a graph if we are going to graph the two given equations. The graph of the first and the second equation in this linear system are lines. And if there is an intersection, then that is the solution. If they do not intersect, there's no solution for that. That is why one of the methods that you could use in solving for this linear system is by graphing. Another method is by substitution. But here, let me use the elimination method. Elimination method means we are going to pick a variable that we are going to remove first so that we will be able to solve the other. And once we solve that other variable, we are going to use it to solve for the first variable that we have eliminated. Part of this video as well is a checking of whether our solution will really satisfy both equations. So let me start by copying the equations here. The first equation is 3x, then minus 4y is equal to negative 6. The next equation is 2x minus 3y is equal to negative 2. In the process of elimination, again as mentioned, we are going to pick a variable that we are going to remove later. Okay. When we are going to remove a variable, we are going to add the two equations. And we are going to apply a mechanism wherein if we are going to add both equations, one of the two variables will be removed. Because if we're going to look at our given, and if we're going to add both of them, none of the variables will be removed here. So the thing here is we are going to multiply a certain constant to the equations. And it's easier for us to multiply a constant if one coefficient of the same variable is a multiple of the other. In the previous videos, we have 2 and 4, so that's very easy. Here, for our x variable, we have 3 and 2 coefficients. So none of them is a multiple of the other. For the y variable, we have 4, specifically minus 4 and minus 3. Again, they are not multiple of the other. So what we could do here is this. We are going to multiply a certain constant to both equations, and that constant may not be the same. My point is this. I'm going to remove x. Okay, let's remove here the x variable. So that's 3 and 2. 3 for the first equation, 2 for the second equation. Their least common multiple is 6. Hence, I'll be multiplying the first equation by 2. So that when I multiply that constant 2 to 3x, I will have 6x. Okay? But don't forget that you're also going to multiply the said constant to minus 4y and minus 6 because it should be multiplied to the entire equation so as we are not changing the equations. Now, since the resulting coefficient of the variable x in the first equation by multiplying 2 will become 6, I need to make the second the equation, the coefficient of x in the second equation also 6, but specifically it should be minus 6. So that when we are going to subtract or add rather, x will be eliminated. So I can multiply this by 3, right? But if I'm going to multiply it by 3, it's just 6x. So I'm going to multiply this by minus 3. And that is also to be applied to minus 3y and minus 2. With these processes, we'll have these versions of equations. You have here 6x, 2 minus 4 is minus 8y is equal to minus 12. That's the version of your first equation with the multiple of 2. And for our second equation, negative 3 times 2x, we have minus 6x. Negative 3 times negative 3y is plus 9y. And negative 3 times negative 2 is equal to positive 6. After doing that, you can see here that if we are going to add both equations, we cannot eliminate x. Leaving with y coefficient, minus 8y plus 9y is simply 1y, or y is equal to, the sum of the constants is negative 6. Okay, so this means that the value of y for this given linear system is y equal to negative 6. This is minus 6. Sorry, let me do it again. Minus 6. Alright, so this value of y now will be used to solve the value of x, and we could use both equations to do this. But here's the thing, okay? I need to show you the value of x using this value of y in both the original equations, because even if it satisfied only one equation, but if it will not satisfy the other, then we can say that there is no solution. Both equations will be satisfied, and the equations I mean here is the original equation. The 3x minus 4y is equal to negative 6, and the 2x minus 3y is equal to negative 2, not the versions, because there might be some errors in the process of multiplying a certain constant. You will be verifying if there is an error once you substitute this on your original equations and it doesn't match. So the original equation is this. We have here 3x minus 4y is equal to negative 6. And let's substitute y equals negative 6 to solve for x. So you have 3x minus 4 times negative 6 is negative 6. 3x is positive 24 is equal to negative 6. Subtract subtract 24 both sides. 3x is equal to negative 30. So x is negative 10 when you divide both sides by 3. So this is the value of x. As mentioned, again, if you're confident naman with your answer, then you can stop here. But as mentioned, you could also verify the same value of y to the second original equation. And if it returns to x equals negative 10, then that means it's better. So we'll have the original equation for the second. 2x minus 3y is negative 2. 2x minus 3, which is the value of y is negative 6, is negative 2. 2x, that's plus 18, negative 2. 2x is equal to, subtracting both sides by 18, minus 20, dividing both sides by 2, x is negative 10. This means that your answer for x is negative 10 using the same value of y, which is negative 6. Hence, our solution here is a point in the Cartesian plane, which is the intersection of the two lines from these two equations. You will have x, which is negative 10, and y, which is negative 6. So this is now the solution for this given linear system. Now, I will move further. If you don't want to hear this, you may stop the video. But this is also very important, as I will check the solution for both equations. Okay? Now, of course, again, as verified earlier, we have satisfied the value of x being negative 10 for the same value of y, and that's already a guarantee that your solution is a solution. But there are instances that you also would really like to check whether your answer is correct or not, so you could always verify this through checking. And by checking, we will substitute the solution, the point negative 10, negative 6, to both original equations, and it should retain balance. Here it goes. The first equation, original, 3x minus 4y is negative 6. I will substitute now the values for x and y. This is 6, right? So you have 3 times negative 10 minus 4 times negative 6, question mark, negative 6. I'm using question mark because this is verification. Even if it's too obvious, I just need to make sure that both sides are the same. 3 times negative 10 is negative 30. Here, that's plus 24, negative 6. Again, if it's too obvious, you simply continue. Negative 6, negative 6. Once you reach here, check. You have verified that it satisfied the first equation. It should stop here, but then again, let me move forward to 2x minus 3y is equal to negative 2, and substitute the same values for x and y. You have 2 times negative 10 minus 3 times negative 6. Again, question mark for verification process. Negative 20 plus 18, question mark still, negative 2, check, negative 2. So, this again, the guarantee that your solution is really the solution. So we did this using process of elimination, and we have verified our results, our solution, the intersection of the two lines is at negative 10 and negative 6. Thank you very much for watching.